Hey, what's going on, guys? Let's do this problem right here. So we have an observer that is standing still, and we have a sound source that is moving away from this observer. That is velocity is given, that's 24 meter per second, and the frequency that source is producing is 500 hertz, and the velocity of the sound is given 340 meter per second. The question is asking what is the frequency that this observer will observe when this moving away with this speed. So let's see how we can calculate this one. So we have f observer, so that is equal to, let's use a different color, f observer is equal to f source v plus or minus v naught over v plus or minus v source, right? In this case, observer has zero velocity, so we can cancel this one right here, and this is going to be velocity of the sound, so this is equal to v. And then we have frequency of the source that's provided, we have the velocity, so let's plug all the values. So we have 500 for the f source, then we have velocity of the sound, that's 340, that's the only thing, and in the bottom we are going to have 340, and this velocity of the source is 20 meter per second. The question is whether we have to put a plus or minus right here. Let's see how we can figure it out. So v is equal to f lambda, right? Now we are dealing with the frequency right here, so let's rearrange this equation, v over lambda. So what happens if the source moves away from this observer? If you notice, the wavelength will increase, because as this move along, it will go far away and the wavelength will keep increasing, right? That's what's going to happen. So what happens if the wavelength increases right here? Wavelength is in the denominator, and if it's increase, this will decrease. So we have to put a sign that will decrease this frequency. So this values are in denominator, right? So if you put a plus right here, the denominator will increase, and that will reduce this value. So that's how we find the sign right here. So we have 500 times 340 divided by 360. So let's calculate this value, and if you plug all this value in calculator, you will get 472 hertz, and this is the frequency that's going to be observed by this observer, and that's how we do that. I hope you guys liked this video. See you next time.